Hello, good afternoon. My name is Song Ko Hang. I'm with Intel. We're going to talk about the OAI Workstream update. Myself is going to provide some update on the high-speed Workstream. And I have our team member, Chuang Ruan from Weaving. He's going to provide the update on the system Workstream. And we have Anthony Chang from Meta. He's going to provide the update on the power Workstream. Okay. So I'd like to provide some update on the OAM 2.0, right? We have been started this project since early on this year, and we have come up with some of the specification that we'd like to share with you guys. And like what Pankaj and Winnie mentioned before, we're going to release the spec by Q2, Q3 next year. And we also have some new definition of the OAM form factor. And I'm going to talk about the detail later on. And also that we're also targeting for the 112 gig beside on top of the 1.5. And also that we're going to look into the Gen 6 as well, PCI Gen 6. And one of the key development that we are targeting on the 2.0 is the OAM is going to support 1 kilowatt or more, because we are seeing a lot of more requests in terms of the new advanced packaging, right, and also the process node. And then all the OEM suppliers, they're looking for more performance, right, in the near future. So that's why that we are targeting for 1 kilowatt and more. So this is the form factor for the 2.0. We actually increase the length of the OEM, and from 80 to 85. And due to some constraint on the UBB, we cannot really increase that a lot. Right? We are trying to push it up to the what we got from the feedback from some of the OEM supplier. Right? We increase it to 85, and also as you can see that right now, and we adding a lot of complexity on the OEM design with the 1 kilowatt. There is a power delivery, the high-speed SerDes routing, and a lot more components going to put on the OAM. Okay. So we're also looking into what is the last budget target that we want to set for the end-to-end channel for the 112 gig. So as on the 1.0, we have the 56 gig PAM4 with the 30 dB. But for the 2.0, we are targeting also in the range of 28 to 30 dB. And we're going to set the OAM still the same, 8 dB. And the UBB is going to be in the range of 12 to 14 dB with the new connector and also the new PCB material. And the next thing is that I want to cover is we also come up with the new topology, right? One is with the 7 scale up plus 4 scale out. And the other one is a switch-based topology. And this is the work that we're going to focusing on, right, in terms of the complexity on the OAM and also the UBB. And we're going to provide more detail later on within the workstream that what is the plan on the OAM and the UBB. Okay. With that, I would like to invite Chuang to provide some update on the system workstream. Thank you.
Thanks, Song. Thank you. Thanks, Song, and thanks, team. I'm Chuang Ruan from Weaving, and let me update briefly about the system workstream. The main topic on this update is that we updated 2 versions. Recently, is a UBB 1.5 version. Its main focus is on the power and the connection. The connection speed is 112 gig PAM4, and the power is supposed to be support 200 watts. And we have a fixture on the Experience Center. And the UBB version 2, as mentioned by Pankaj and Song, is the design goal is to support 1 kilowatts, and for high-speed connection, 112 gigabytes PAM4, and also want to take the design and design challenge with scale-out ports to 32. So this is, OK, I'll be quick. I'll be quick. So this is second slide, and I received the notification. OK, that's all. I'll be quick. So this is for this version 1.5, because we provide the text features. So it has some materials try to use to reference design and try to let SI to evaluate the extreme or hyper low loss on the material transmission. And this is also try to incorporate new Molex Mirror Mesh Pro connector, which you can see the real product in the Experience Center. OK, these are the text fixtures for the 112 gigabits connection. And these are the, we are designing the version 2 of the UBB. And you can see on the right, there's scale-out connection design, scale-out ports that looks like this. So that's all. Let's see Anthony for the power portion. Thank you.
Yeah, so from the OAI Workstream side, we also have some updates from the power side, mainly two topics, very similar. So UBB 2.0 and also the OAM 2.0. So from the UBB side, we have some major changes from the existing 1.0 design, right? So I'll highlight a few of the major ones. So one major change is we are looking at a singular modular power distribution board approach. This is a different angle that we're taking it, and mainly because this helps to do a lot of the simplification on the power delivery tree for these sort of OAI system. And another thing also as part of the OAM 2.0 is we are looking at the 48 volt input only. So this helps to simplify the design a lot by not needing any more 12 volt bus directly to the OAM. And this definitely helps to do a lot of the optimizing the end-to-end power efficiency, as we do not need to use as much copper on the 12 volt, and we can allocate all of it into the 48 volt domain. We have a lot of work to do here in the optimization, but these are some of the highlights. Another thing, as Song hinted to, we are doing a little bit of the changing on the pin mapping. One of the key changes is we are now doing a dual power entry on the module side. So you can now implement 48 volt or 54 volt input on both sides of the connector. Each side will be able to support up to 1 kilowatt. Yes, and the other thing I want to also introduce is a overall excursion design power guidelines that we're trying to push for with the 2.0 generation. In general, excursion design power has been a very challenging topic within the industry. There's a lot of scenarios where it creates stranded power in a data center where we need to subscribe significant amount of overhead to support these high training workloads. So fundamentally, I won't go over all the detail here, but basically we would like to create a guidance in terms of how we can come with a alignment on a common EDP profile, and that way there is a way to basically advertise that we are being compliant to a certain ecosystem. All right, thank you. And call to action, feel free to join us on the OCP server project and also the mailing groups as well.
Thank you so much.